Okay, good morning all. Welcome to another session of our seminars and data science for society. We have continued on for, I think now 2 months or a little bit more, of covering many topics around wider being data science. But for the next few ones, we'll be looking at kind of the areas of natural language processing, especially in trying to understand better some of the kind of work that's cutting edge that's going on with local languages. Just FYI, we typically have a talk for about 30 minutes or so, or 30 to 40 minutes. And as you hear, we are in a part in South Africa right now. We're going through load shedding, which is our rolling blackouts. So we'll be on here the whole time. There's been some contingencies that are put together to make sure that we can do this. If you can wait for your questions at the end, we'll have about 20 to 25 minutes of Q&A. We normally start right at 9 a.m. South African time, and we try to make sure we finish at 10 so that you start your morning, you get kind of your jolt of machine learning or data science, and then you can go on with your day. Today, we have Jesujoba Alabi, who is a computer science student at Saarland University. I'm trying to finish reading. And then my computer is doing its own things. Okay. Yeah, he's a computer science at Saarland University. He was a research assistant at the Multilingual and Language Technology Research Group at the German Research Center of Artificial Intelligence in Saarbrücken, right, where he's currently doing his master's. He's a research assistant at the Database and Information Systems Group at Max Planck Institute for Informatics, where he works on Q&A systems, and his research interests are in machine translation, NLP for low resource settings, information extractions, and Q&A systems. So today he'll be talking about massive versus curated embeddings for low resource languages. So yeah, I'll hand it over to you, Alabi.
Hi everyone, good morning. Thanks for inviting me. Yeah, so I go ahead to share my screen. Yep. Ready? Can you see my screen?
Not as yet.
Okay. Sorry. Yeah. So once again, yeah. So I'm here to present a paper titled "Massive versus Curated Embeddings for Low Resource Languages: The Case of Yorùbá and Twi." The paper is jointly authored by myself, Kwabena, David, and Christina, and it was accepted at the 12th LREC conference, though the conference didn't hold, yeah, but it appeared in the conference proceeding. Yeah, so to the outline of the presentation, we have a brief introduction on motivation, the languages under study, which is Yorùbá and Twi, the data and the data collection procedure, the semantic representation approach we used, the experiments we carried out, then a conclusion. Yeah, so to the introduction, in recent years, a lot of a lot of architectures has been proposed to learn semantic representation from on annotated text, which is a cheap approach. And during evaluation of these approaches or architectures, this is usually done only on languages with a lot of resources, which we can refer to as rich resource languages, such as English, French, German, etc. And it is always assumed that whatever performance that is seen on the high resource, in the high resource case will extend to low resource cases. But this is not usually correct, or this is not usually right in most cases. So that is kind of the motivation for this work. And as a result, we had like 4 objectives. And the first one was to investigate the quality of word embeddings on 2 African languages. And like I said, we considered Yoruba and Twi. And for the word embeddings architecture, we considered fastest and BERT. In 2018, Facebook released word embeddings for 294 languages. And then later, they also came out with another one, which is for 157 languages. For the 294 languages, the models were trained on just Wikipedia and Common Crawl, while for the 157 languages, it was trained on just Wikipedia. And then the following year, also we had BERT, which is a mixed language modeling architecture based on the transformer. So we considered these 2 because they had embeddings. In the case of fastest, there was embeddings for both Yoruba and Twi. And in case of BERT, the multilingual BERT, Yoruba was part of the languages used in training the model. So second objective was to learn our own word representation. And in this case, we needed to create our own data set. And then we trained our own models using fastest and joint character word embeddings. And we then decided to compare the pre-trained, the one gotten from Facebook and Google, against the one we trained. And lastly, we analyzed the impact of adding noisy test to our own curated test. Now, to the languages under study. Like I said, we considered Yoruba and Twi, and Yoruba is a language spoken in Nigeria or majorly West African countries, also in Caribbean countries with over 50 million speakers. And Yoruba has 25, in its orthography, it has about 25 characters, and it excludes C, V, Q, and Z. And Yoruba is a tonal language, which is usually indicated with diacritics. It also uses underdots. Now, most of the resources online for Yoruba either uses the correct orthography or they replace the diacritized text with undiacritized text. So looking at the tree on the right in this slide, we have a word OWO at the root node, which to the best of my knowledge doesn't exist in Yoruba as a word. Yeah, but on in the leaf nodes of this same tree, we have this same OWO existing in different forms based on the way the diacritics are placed, as well as the underdot. And usually this is a kind of way of disambiguating some of these words, although when they exist in context, they could also mean different things. However, this kind of word OWO would exist in most of the resources online as partially diacritized, which is what we have in the level 1 of this same tree. And Wikipedia, which is like the resource in chief, is not an exception. Also, Yoruba, before we had this paper, had no evaluation data set, and we needed to come up with some task and data set. Also for Twi, Twi is a West African language spoken by most people in Ghana. It also has 22 alphabets, and it is also a tonal language, though in this case without diacritics. So for example, a word PAPA could be pronounced as papa, 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 and it could mean also different things based on the pronunciation. And learning representation for this kind of language is kind of dicey because you also need most of the times conceptual representation for it. And most of the tests also online based on analysis. Some of the tests has been anglicized. For example, I being replaced with E. Also, there are a lot of Twi belongs to the class of Akan languages, and sometimes people write related people replace the real Twi word with closely related Akan word, and then also Twi had no evaluation data set before we had this paper, and people also write Twi tests using different dialects, because Twi also has different dialects, just like Yoruba. We also have different dialects for Yoruba. So to our data set, so we needed to create our own data set, and all we did was to categorize the data set we had into 3 classes. So we had the first data set, which we refer to be clean. And when we say clean, we mean, in the case of Yoruba, well diacritized with the underdots, and that's what we mean by clean or quality data set. Also for Twi, it means there were no issues like we have raised in the paper. And then we had the second class of data set, which is, in the case of Yoruba, we used the C1, and then we added BBC Yoruba. So BBC Yoruba is a news website with different articles, but without, mostly under-acritized text, and they have underdots in most cases. So for Yoruba, it is the clean and BBC Yoruba. And for Twi, we added the Bible, because for the clean data set, the basis was the Bible. And the Bible is the most available resource for low resource or endangered languages. And that's the motivation for using the Bible in this case. So for Twi, it was the Bible and Wikipedia articles. That's what we have for the C2. And then lastly, we had the class 3, which is the large data set, which is the combination of C1, C2, and every other resources we could gather online. And the table shows how we splitted them, the number of tokens and every other thing. Now, we needed to define an evaluation task and the metric to use when we have learned representation for these languages. So because we are working on word embeddings, then we needed to define an evaluation task that we can use the word embeddings to depict. So we used the word similarity task, and what we needed to do, which is also a contribution of our paper, is to translate the word sim353 data set from English to Yoruba and this we got done by involving some locals in Nigeria and Ghana to do the translation. And we used the metric Spearman's correlation in this case. So we trained both fastest and joint character word embeddings, and we evaluated the models using the Spearman's correlation metric. And then because we had Yoruba included in the BERT model, I mean the multilingual BERT, we also defined a name entity recognition task, and this is more of like token classification. So for example, as we have in the image, Cindy is going to Germany tomorrow. Cindy is a person, German is location, tomorrow is a date. So that is like what we are doing in the case of Yoruba. So another thing we did was to create a data set for this task. So we had this Global Voices news website that has a lot of news articles in Yoruba where they are criticized. So we involved some locals to annotate this data set, and we trained, or we fine-tuned the BERT model, and in this case we used the F1 score as a metric. And now to the semantic representations we used. So we used the joint character word embedding and the fastest for word embeddings, because one, these languages are low resource and they are prone to out of vocabulary problem. So joint character word embedding and fastest are based on the widely known word-to-vec architecture. And what they do is to jointly learn word embeddings as well as character embeddings. And at the end of the day, they kind of sum this representation to make a particular word embedding. And for BERT, it's a max language modeling architecture that is based on transformer, and it's heuristically learned byte pair encoding heuristics. And now to the experiments we conducted and results. So having trained our own fastest and joint character word embedding on our own curated data set, and based on their classes, C1, C2, C3, we compared our results to what is available from the pre-trained embeddings from Facebook. Now, if you look at the table we have here, we have like 2 pre-trained models. Like I said, Facebook released 2 pre-trained models. One was trained on Wikipedia, and one was trained on Common Crawl and Wikipedia. So for TWI, we have for F1, the first model, a vocabulary size of 935 and a spearman's rank of 0.143. And you check our own model, which is the curated small data set C1, you will see a huge improvement, which we can justify by saying, okay, we had a larger vocabulary size. But looking at what happened in Yoruba, even from the model from Facebook, we have a vocabulary size of 21,730, give a better spearman's correlation as against a vocabulary size of 151, which one would have expected to give a better spearman's correlation. But when we observed the vocabulary of this model, the one trained with Common Crawl and Wikipedia, we discovered that out of this 151,000 words in this vocabulary, about 235,000 of them are non-Yoruba words. They were either English, Arabic, or French. And that is kind of the reason why this model with a high vocabulary or large vocabulary performed poorly. And when we trained our own model, we observed a better spearman's correlation, even with just 12,000, which is even below the vocabulary for Wikipedia only. And for TWI, adding some noisy test, which is like combining the Bible and the Wikipedia articles, improved the spearman's correlation from 0.354 to 0.388, because in a way, Wikipedia kind of debiased the Bible and even added more words to the vocabulary. However, adding some noisy tests in the case of Yoruba, which is adding the clean and the BBC Yoruba kind of made the model more ambiguous, I would say. So when we had a lot of diacritized tests and we added undiacritized, then there was a lot of ambiguity, and that is a kind of reason why the spearman's correlation reduced in the case of C2. However, in C3, Yoruba kind of had a jump to 0.391, and one of the justification for this is some of the tests we added were well diacritized. For example, in this third class, we used JW300, and is a well diacritized corpus. And we observed the same trend when we used the joint character word embedding. However, for TWI, we have a better spearman's correlation, but for Yoruba, it was not that better than fastest. And one reason we can give is the characters were very important in TWI, unlike in Yoruba. Now, we also continued experiments, and we evaluated the pre-trained multilingual BERT. And the first table shows, the table by the right shows the distribution of our data set, the one we created. and the entity type. So we had organization, location, date, and person. Also, we have orders. And we have the train, test, validation split. And evaluating the pre-trained uncased multilingual BERT on this data set, we had an F1 score of 27.1. We then fine-tuned this multilingual BERT using multilingual vocabulary. We had a jump from 27.1 to 56.4. However, we fine-tuned it with just Yoruba vocabulary, and we got a boost in the F1 score by about 4.56 F1 score. And the reason for using the uncased multilingual BERT is because if we use the cased multilingual BERT, when it sees what starting with capital letter, it can easily predict, okay, this is a person, organization, or whatever. But in this case, we made it kind of neutral, so it needs to really learn something to be able to predict what class each token belongs to. So in conclusion, in this paper, we presented curated word and contextualized embeddings for Yoruba and Twi. And then part of our contribution is the creation of and defining of evaluation task for these embeddings, and then also the name entity recognition task for contextualized embeddings. And we discovered that the massively generated embeddings, which are the ones used by the Facebook and Google, performed poorly in this case, which is for low-resourced languages. And that is the end of my presentation. Thank you for listening.
Okay, thank you for that presentation. I think while people are forming their thoughts, if there's questions, you can, as I said, I am being load shed, so this is better. There will be a ping and the background noise on my side. Yeah, it's very interesting, I guess, work in this space, and it's been very interesting to see, especially going from these pre-trained embeddings that come from Facebook or Google, and then seeing what the limitations they might have in low resource languages. Maybe to kick off, while we wait for other questions from the participants on here, do you have a good understanding of, did Facebook just use their content, or did they try to crawl many sites? I'm trying to think, like, or did they just take a shortcut and say, yeah, we did it for this language because we found one data set somewhere and we put it in?
Yeah, so for Facebook, like I said, they released embeddings in two folds. So they had one for 294 languages and the other one was 157. And in the case of 294, they just used Wikipedia. They just crawled Wikipedia and trained fastest on just Wikipedia for 294 languages. And for the 157 languages, they used Wikipedia and Common Crawl, which is everything they could find online for these languages. And one thing is very important that, for example, in the case of Yoruba, which uses diacritics, most of the resources online are not well diacritized. So they didn't probably take care of the quality, just felt, oh, the resources are there, just like English, that probably there's no need of diacritics or on the dot. Everything is well written, let's just use and train. But that is not the case for all languages. Okay, also, I told you earlier, we worked on SOSA for a paper we submitted to EMNLP this year. And fine, I might not understand SOSA, but I think I've seen a lot of tests in South African languages, and usually they look alike to me. And we feel, because when we evaluated the model, it wasn't so good. And then I said, okay, it's possible that for SOSA, they created all possible data sets and for South African languages, and they assumed it is SOSA, which might not be correct. So maybe part of what they created probably we have isiZulu, Setswana, and the rest, but they didn't give time to probably check or understand these things.
Okay. Oh yes, and again in the language it will be pronounced isiXhosa, Xhosa. But yes, we do get that. Wondered if there were any questions from participants on the call. Because I can bring up another question. I guess that's general. No other questions from, you can unmute yourself if you would like to speak. Okay, Zola.
Hi, sorry about that. I was trying to work out the interface. Like, it's one of the few times I'm using Zoom. But anyways, I have a question about generalizability. So I see a significant portion of your corpus, right, is the Jehovah's Witnesses Bible. So I'm curious as to, like, all the times we're having errors, right? Is it not due to the fact that there's a difference in the language between the Bible and contemporary use of Twi or Yoruba?
Yeah, so we understand that, and that also kind of showed in the performance we had in our experiments. When we, in the case of Twi, most especially when we had just the Bible, we had a small vocabulary and the Spearman's rank was 0.354. But when we added Wikipedia, which is kind of a general test, which is not kind of biased, we had a better Spearman's rank correlation. And this kind of shows that, okay, the Bible kind of biases whatever model we have. So we need more tests from other sources. So in other words, using just the Bible would likely not generalize well in most cases. So there's need for us to get more data. But the reason for using the Bible, like I said earlier, it is the most available resource for low resource or endangered languages. And that is just why we had no option. We had no option. So we just needed to use the Bible as it is. Yeah. So I think it's just important for Africans to create their own data set, and we can have unbiased and more generalizable model.
Okay, thanks for that. Are there any other questions? Or maybe a follow-up question to that. Have you guys given any thought then to, Kwame, I'll recognize you second next. Especially this question of bias, right? We, at the moment, we're doing it kind of extrinsically. We're saying we're having good performance in general because we're evaluating, let's say, on the word sim that's translated. But is there a way that maybe we can do a more direct evaluation of the diversity of a data set before we pump it into any learning model?
Yeah, I'm not very conversant with researches on biased models, yeah, but I feel probably the intrinsic or extrinsic ways of evaluating can sometimes show how biased models are. But for me, I don't really have much experience in correcting biased models or how to experimentally check how biased our models are.
All right, thank you. Kwame, you can go ahead.
Okay, good morning, guys. So, Alabi, I think that was a great talk and I enjoyed it. And I think for a point of question, the name of the is Tree.
Yeah.
Yes, Tree.
Yeah.
Good. But I mean, I don't know if my question falls into this scope, but like with all this work on languages, do we think we are doing enough as Africans with respect to our languages being transcribed locally? And do we see our languages surviving the next 1,000 years?
Thank you for that question. Do we see our languages survive? I'm not very sure. I'm not sure our languages will survive. We need to do more. We need to do more because, for example, I was discussing with a senior colleague. Okay, over here in Europe, people kind of voluntarily translate Wikipedia articles, but in Africa, people don't. I think I understand the situation in Africa, but we need to do more if our languages will survive the next years. So for me, we are not doing enough. And I think starting from each and every one of us, we need to, especially those that understand the languages, we need to also work to ensure that we have resources online. For example, translating Wikipedia articles and doing some of these things bit by bit. I believe we can have the languages survive, but with the way things are going for me, I feel some of these languages will not survive. I think for some languages, people are doing a lot of recent, but for some, I don't know. So I think it's 50-50 for most of those languages, yeah.
Hercules, you can go ahead.
Thank you so much, and thank you so much for that very, very insightful presentation. The question that I have follows on to the previous question, and that is, what kind of unique strategies can you think of that we can use in order to enhance this level of engagement, specifically with languages that tend to be driven by communities that are more rural than urban? So you would find that in language-sparse environments that there are certain communities that have their own unique dialect or nuance to a particular language. And the risk is if we don't capture that information, then it might get lost over time. So my question is, in your context, what kind of unique data capturing strategies have you thought about to bridge that gap?
Yeah, I think one approach is what I think AI for Development did of recent, which is giving out grants or funds to people from some of these regions to get data available. And I think for now, probably that would be the best approach I can think of that would work in the case of Africa. So I think we need more funding to get people to get, because in a way, we're also having lack of experts. Now, for Yoruba, find a lot of people can speak, but when it comes to writing and probably putting the diacritics, a lot of people cannot. And in a way, this set of people are kind of facing out, they are kind of leaving. So this is the moment we need to get more grants to get people like that to fix all the tests we have so that we'll have quality tests in the future. So I think for now, I would say it's more about funding and maybe encouraging here, but I think funding matters most at this moment. Yeah.
Okay. I think there was also a question. Musedi, can you just ask your question?
Oh, sorry. Oh, hi. I really like the work and thanks for the presentation. I just wanted to find out, in terms of when training the models and maintaining consistency as to what you're putting into the models for both cases, I was just wondering, how much emphasis were you putting on the type of pre-processing that was done? For example, in training fast text, or in the pre-training that was done by Facebook, and what you followed yourself in training your own model. And I asked this because what I found was when I look at like a source like Wikipedia compared to the Bible, those two would have very different text within it, and the type of noise inside that you'd have to see through would be slightly very different in both cases. So I was just wondering how you maintained consistency in those two cases to make sure that that is a fair comparison to a pre-trained fast text or something like that.
Okay, you mean comparing our own pre-processing pipeline to that of Facebook? Yeah.
Also on your own pre-processing, what do you think, what type of steps did you take that you felt you would strongly advise to use in terms of for languages where English becomes a more like noise in the language?
Yeah. So for us, I would say probably we didn't have English, or for the clean, especially the Bible and some other corpuses, for example, in Yoruba, majorly they are Yoruba text. So, and we were kind of sure of the quality. So we didn't have to do much pre-processing steps. And also the same applied to Twi for the Bible. So all we needed is just to tokenize text. And we could do probably little also on Wikipedia. So because we know it is noisy and we were not ready to clean, because we understand that was what Facebook used as it was. So we didn't do much kind of pre-processing more than tokenizing the text. Yeah, so, but if you want to do pre-processing for some languages, probably where you have English text, there is a language detection tool which you can use to identify some of the English words and remove them. But for us, we understood, or we understand that Wikipedia is noisy for Yoruba, and it was used like that by Facebook. Then we also decided to use it the way it is in our model. But for our clean data set, we were sure it is clean, and we had little or nothing to do to pre-process it than tokenizing the test.
All right, thanks.
Thank you, Tepiso.
Hi, good morning, everyone. Yeah, I just have a simple question. So, for example, I can speak my home languages, but I can't write in my home languages at all.
Tepiso, can you be a bit louder?
Oh, okay, cool. Can you hear me now?
Yes.
Oh, okay, cool. So I was saying that, for example, I'd like to be an active editor and translator. However, I know that myself, I can speak my home languages, but I can't spell. I do not know how to properly spell in my home languages. And I know that that happens for a lot of people as well. So for people like us, how can we be active editors? And is there a way of bringing people on board who can speak their own home languages, but they can't really type in them or read in their own home languages? Thanks.
Yeah, so just like I said, in the case of Yoruba, we have people who can speak correct Yoruba language, and they cannot write, or they cannot apply their critics, which is one thing that like the real Yoruba people want to have on their test. Yeah, so for now, I believe there are still some people who have this knowledge. And I think that's one of the reasons why we're also training models like this, because we believe, for example, in the case of Yoruba, if we have good tests, we can have good translation model, we can do different NLP tasks. So a way we can learn is if we have models that are working, people can probably learn from such models. And then since there are still people who understand this language, I think a way to go is to learn from them. Because they have this knowledge. I think at this stage, I believe in Africa, we need to share more knowledge and not to be told some of these things. Because if a language, like I said earlier, if a language will still be available in the next 100 or 1,000 years, this knowledge about our languages, we need to share them. And the one way is to digitize this knowledge, or our tests, our corpus, or everything. Yeah. So for someone like you, I think one way is probably to get people, those experts, who probably cannot access the internet to share their resources or their knowledge, probably to learn from them. Yeah, because if the resources are not available, or the knowledge is not available, I'm not sure how well you can learn such language. Yeah.
Okay, thanks. I think, Michael, may you want to put in a comment about this?
No, thank you. I'm just writing another comment in the comments about forming a a group of people that are willing to undergo a training, because we do have online training to become a Wikipedia editor. So that's very easy to arrange. I'm just about to enter that comment on the chat.
Okay, thank you for that. Yeah, I think a question for me, okay, my last one, Alabi, was especially on the
Can you speak louder, please?
extrinsic evaluation. So how was the choice of named entity recognition come by?
Yeah, so when we decided to work on BERT as well, then we decided to think of, okay, what kind of task can we work on? At the point we were like, okay, maybe sentence similarity task. And then, okay, we said, oh, since we have news articles, which is of good quality, then we should get people to annotate. And all we needed was just about 25,000 tokens. So all we did was to just reach out to people who did the annotation for us. And I think it was a good choice for us, because we were thinking, okay, maybe we just have 2 sentences in Yoruba and they score just like word similarity. Yeah, but we said, okay, fine, since we have tests, let us annotate these tests and do named entity recognition instead of sentence class. We could have also done topic classification, but there was no data set as at that time. So I think the first test, or the easiest we could have done, was named entity recognition.
Okay, thank you. Zola, you can go ahead with your question.
Okay, thanks. So I was looking at the slide where you have the data sets you're using, right, from C1 to C3. And one of the things I noticed here is that for someone, I think you said Twi, but someone corrected you. I'm not sure which one, how to pronounce it now, but I'm going to say, no, sorry if I'm offending anyone. So if you look at Twi, right, versus Yoruba, there's a very low difference in the correlation on Twi, despite the massive increase in the token size. But that's not the same for Yoruba. I'm just curious as to, have you tried to at least investigate why that's happening for Twi?
Yes, so I think one of the things we discovered was that there were a lot of mixture of dialects in the C3. So a lot of Twi dialects were in the corpus, in the C3 corpus. And that that's like the reason why the correlation actually dropped. So but for Yoruba, one of the major corpus we added to C3 is JW300, and it was well accredited and is the standard Yoruba. So that is kind of the justification for, and then the vocabulary size for sure increased greatly for Yoruba. So that's kind of the reason why we observed this better performance in Yoruba. But for Twi, we discovered there were a lot of Twi dialects in the C3, and that kind of gives the reason why we have this little drop in correlation.
Thank you for that. I don't know if there's any more questions from anybody on the call. Yeah, if not, I think on my side, sorry, I want to thank Alabi again for coming through. I think this was very much a very interactive talk compared to also our other past ones. And thank you also for sharing yourself and sharing your time. I would also like to thank everybody who's on this call. I think I've shared just some links on just joining our mailing list and keeping track, and also you can suggest a speaker coming in the future. Alabi, I would ask, is it possible for you to share your slides? Even like you can email them to me and I can upload them on Google Docs.
Okay, I will do just that.
Yeah, there will be for everybody. Hopefully, we'll get the recording later today and upload it as well. And then the slides also will be available on our blog, on the research group's blog, so that you'll see. For every other past talk, we do the same thing, so that people can actually also be able to interact with the speakers afterwards. Right? It's not just about having a talk and then people disappear. But we can see, especially in this area of work, that there's a lot of enthusiasm. Right now, we're trying to figure out how do we tap into it in such a way that we can do great work around low resource languages. And some of it does end up being preservation, right? We're very worried about languages not being there. And we have to be cognizant of the fact that if we're not digitizing, if we're not building tools like machine learning or NLP tools, then we're getting closer and closer to languages actually somewhat extinct in a way. So thank you, Alabi, for your work in this area. And
thank you for having me.
I was very excited to look at it and see that he's being thing. I had hoped this year to spend some time in Ghana during their data science, the data science Ghana week, and then I wanted to actually go visit some universities and see people working on Twi and understanding kind of what are the challenges that are there. But it's been very good actually. Also live parts of that by watching your presentation. Thank you, everybody, and enjoy the rest of the morning, or very early morning for Yumseli in San Francisco. And yeah, we will be having a talk. The next one we're just finalizing. It might be on speech, and then the one after that also will be the announcement of the Lacuna Fund in terms of the NLP funding. Funding that will be available for people to actually curate and collect natural language processing data sets for under-resourced languages. So maybe that's another thing. So I'm hoping to host that on the 2nd of October. So you will get that. If you're on the mailing list, you'll get the invitation for that one as well. All right. Thank you, guys.
Thank you so much. Have a lovely day.
Thank you very much. Thank you.